This is the Liquid Freezer 3 Pro in 360mm, the next iteration and hopefully better performing upgrade of the iconic Liquid Freezer 3 lineup. And before you think this thing is so much better and Arctic just invented a new formula for cooling down stuff, wait a bit, because I have so many mixed feelings about this, and it's so complicated, so much more complicated than what I hoped it was. Now, I gotta say, Arctic did a horrible job of explaining what exactly changed from the non-Pro to the Pro. The only obvious thing are these overpowered Arctic P12 Pros. These are up to 3000 RPM quick spinning little monsters that are pushing up to 77 CFM at up to 6.9 mm of H2O. And these are not to be mistaken with the P12 Maxes. They are spinning slower and they push a bit less air, but thanks to the new 7-blade wing design, which unfortunately does come with a giant central hub, which has a whole other effect on cooling on the radiator. Anyway, compared to the P12 Maxes, they are pushing at a much higher static pressure. Other than that, there is no physical difference or no other physical difference to the original LF3, and I looked for it extensively. We still got the exact same 38mm thick radiator at 15 FPI, which Arctic unfortunately kind of sold as a new idea on their website, but that's besides the point. It is connected by rather thick 450mm long tubes that are adjustable at the water block, exactly as it was before. At the water block end, we still got the 45 by 40mm copper plate underneath the water block pump combo with magnetically attached VRM fan. And yes, the cold plate itself also seems to be of the same thickness, and I tried to measure it as accurately as I have the devices to, and it's the same thing. And just like with any other Arctic Liquid Freezer 3, everything is pre-mounted, and you can use either this cable here to control everything of a single PWM plug, or this multi-cable allowing you to set the fan, VRM fan and pump speed individually, which by the way also seems to be exactly the same one as we had before. To connect that cable, we need to remove the VRM fan and pre-connect it next to the pump, and just to make sure to route it properly so that the VRM fan later attaches as it should. Oh, and if we are already here, the VRM fan itself also seems to be like the really exact same one, up to 2500 RPM quick. And just as a quick reminder from our very first LF3 video, we benchmarked that fan back then on our usual Intel test bench machine using the 320 watts preset and compared it to the second gen Liquid Freezer 2. We saw that the VRM fans dropped by 11.5 instead of 3.9, 6 instead of 2.7 and 13 instead of 5.3 degrees C, depending on the VRM sensor we were looking at. And overall, the difference that this somewhat small fan can make is potentially huge. But that's not to say that not having it will light your PC on fire, but having it dropped one of the sensors by 13 degrees, so yeah, it has a big impact. Here I just wanted to disclose that I didn't specifically benchmark the fan on the Pro again, but I was able to just take one of the older liquid freezers and slap it on this one, and literally nothing changed. It's the same fan, and Hardware Info told me the same speed that I had with the other fan, and I could interchange them and nothing changed. It's the same fan. Anyway, one of these Liquid Freezer 3 Pro in 360s comes in a very regular Arctic style packaging containing all the mounting hardware for all nowadays relevant sockets, but here comes the other major change. As for AMD, it is still identical, or at least I wasn't able to find any difference. But for Intel, Arctic switched things up. We still got that replacement contact frame, and on the back end there are minor differences. Like for example, now we got grooves instead of a straight indentation, let's say, possibly to even out the pressure, who knows. But the main difference is with the location of these holes. Now they are much more towards the top end, pushing the center of the cold plate up. And that's not random. Similarly to, for example, AMD, where we are much better off with an 8mm offset towards the bottom, Arctic seems to think that pushing the center of the cold plate up would improve on Intel. If that is true or not, we will see in a minute, but Arctic has released some bold claims when launching this thing. And they are not the only one who think that this is the way to go, because if you look at Nokia's upcoming roadmap, there is more of this coming in the very near future. But the claims are still bold. They've got two graphs. One is for an LF3 360 versus 360 Pro, and they claim an almost 10 degrees C drop at full speed on a 285K, which That is bold. Now, of course, you've got 3000 RPM fans on here, so obviously this thing should beat the original's ass. But I know how an LF3 with P12 Maxes performs, and the cold plate was the limit back then. So that can't be the whole story. Brute forcing doesn't go that far. On the other hand, we got this noise normalized graph, which shows that even normalized down to whatever 28 dBA means in Arctic Slab, the improvement still is close to 10 degrees. But that's not all, because they have also said that on a Ryzen 7 950X, the benefits might be smaller, but they are still there, almost 4 degrees C at max and about 1.5 degrees once you normalize them. But do these claims really hold up? And before we cover that, let's just go over the installation. To get the cooler going on Intel, we need to place the motherboard onto something that provides some back pressure onto the socket itself and make sure that we got a CPU in there and keep the socket open. From there, use the provided Allen wrench to remove all 4 socket screws and take it away before replacing the top and bottom ILM part and replace it with the provided Arctic contact frame with the arrow in the bottom left corner. From here, use the new screws with the Phillips head and screw them in using an X pattern and only a few turns at a time, and continue to do so until each screw is all the way in. Over on AMD, it's much easier. Remove the original retention brackets, replace them with the provided mounting clips with L and R being readable, and screw everything down. From there, on both sockets, thermal paste, position the VRM fanless combo onto the chip with the tubes in the bottom and then screw it down. And reinstall the top cap, which will now go all the way in because the screws aren't blocking it anymore. And now, let's get to the benchmarks. First up is Intel, where we benchmark on top of a 3900K using 3 presets, 120, 250 and 320 watts. We always start at 100% fan speed and slowly lower the fan speed in 10% steps while zoning down the noise to create a noise to performance curve. The pump always at 100%. At 120 watts running through the socket, aka gaming, the Liquid Freezer 3 Pro in 360 didn't really shine that much. Keeping the temperature at 28.9 degrees C above ambient, it's not a bad AIO, it's right in the middle of the blob of good performing AIOs. Honestly, I just expected better than this. On the whole list, it did outperform the original 360, sure, and it's now much closer to the original LF3 in 420, but it's just nothing revolutionary. The noise to performance graph for 120 watts also starts to show why I got an issue with this supposed upgrade. Sure, it's kept the chip colder than the original 360, that's absolutely true, but at a huge cost. A cost that even when I lower the fan speed down to 30, it didn't really outrank the original LF3 in 360. It had its moments here and there, but overall at 120 watts I wouldn't describe this as better. But my main issue comes when I compare it to the LF3 in 360 Max, which, if you haven't seen these videos, is just a regular LF3 360 where I strapped a bunch of Arctic P12 Maxes on there. And compared to that monstrosity, the Pro just loses across the board. Except for the very, very bottom, because the Pro actually reaches noise floor, unlike the 3 P12 Maxes, which just don't. But it's not better. But that was only 120 watts, and who knows, maybe this thing needs some heat to shine. At 250 watts running through the socket, things start to look better. Keeping the chip at 53.6 degrees C above ambient, the LF3 Pro in 360 now landed in the top 10 of all coolers we have benchmarked. But compared to other LFs, it kind of stayed the same. The LF3 Pro is still performing roughly like a regular 3 in 420, and it is still like 0.9 degrees C in front of the regular 360, which, just as a reminder, is like 10 times less than what Arctic's advertisement suggested. I mean, don't get me wrong, it's still a very good result overall, a very, very good one. I just expected better. But what about the noise to performance? Well, it's better and worse at the same time. Compared to the original deal, it still doesn't match. Once we normalize it down to the original's noise level, the original is better. Or on my setup, it is better. And the only point where I can say the Pro is better is if we go even lower than that. We actually need to get to the point where my dB meter gives up, because the Pro reaches noise floor slightly faster than the original one, hence the curve at the bare minimum is minimally better. And compared to my max-tuned one, for the majority of the spectrum, 3 P12 Maxes are better. And it takes until 50% fan speed and lower for the Pro to take over. Okay, 250 still wasn't enough, so what if we crank it up even further? At 320 watts running through the socket, the Pro kept the chip at 72.4 degrees C above ambient, still close to the 420. But now 2 degrees C in front of the original in 360. So we finally got something out of these 3000 RPM fans. For the overall placement, we still got a very good AIO, 8th spot this time, so overall very, very good. But the noise to performance ratio, on the other hand, is just the same thing again. Just like stretched out. It had a really hard time to get to the noise to performance ratio or level of the regular 360, and it takes a lot of slowing down until it can match and beat the 360 with P12 maxes. So what is going on here? Now, I don't want to say or suggest that Arctic oversold this thing using these graphs. The simple or the first very important lesson here is that I got the wrong CPU. I cannot verify whatever Arctic is claiming there because they are using a 285K and I'm using a 3900K. And when Intel did the switch between LGA 17 and 1851, they might have kept the same cooler standard mounting system, standard, the hole spacing, thus making all coolers compatible between 1851 and 1700, which was great for all of us. But the overall changes created a hotspot shift towards the top. AKA, if you got a CPU, the hottest spot is now not somewhat centered, leaning slightly towards the top, but now it is clearly towards the top. Thus, Arctic created an offset mounting, which is a perfectly valid idea for everything what's Intel 15th gen and later, but because the cooler is also compatible with LGA 1700, you can get into a situation where you have a 4900K, 13900K, 12900K, where the benefit of an upgrade is or are much smaller. I'm not saying zero. We saw, for example, on the 320 watts workload that we got 2 degrees C of a temperature drop between the original 360 and the 360 Pro. Now, I specifically asked Arctic if they also did benchmarks on an older CPU, and they sent me back a detailed enough table where they benchmarked a 4900K, and they had a difference, still not as significant as they show on the website. It was, I think, 5 degrees C from max on the 360 regular to max on the 360 Pro, but they also had a much bigger, much more positive difference, noise normalized down to whatever they call 28 dBA. However, in my specific case, I am benchmarking using a 3900K, so we go back one generation further, which can have again a significant impact, and that's maybe, or I believe that's the reason why I got a difference of only 2 degrees C. Now, for the noise to performance ratio, why I didn't see any update. The funny thing is, if you choose to look at the right spots, I can kinda replicate a minimal version of much better max performance and much better noise to performance. Because if I look at my noise floor using my dB meter, and we zoom in all the way onto that graph, if you take that 35.5 noise floor, that is a big difference. That is in fact a big difference. And if we look at the max, that is also a big difference. It's not quite 5 degrees C, which they found on a 4900K, but I also got a 3900K. So, and we have a different workload, and I don't know which benchmarking software they use, so it doesn't really matter, but we got a difference, a big difference. So if you cherry pick these spots, you got a difference. But because I do a noise to performance ratio across the whole line, yeah, I just don't see it. I think I will definitely, I believe I will see it if you test it on a 285K, but in my specific case, I just don't see it. I was very unsure with my result. That's why I also asked Arctic to verify or to see if they have alternative results which they could provide to me. But I looked online and I found somebody else, some website, where they benchmark using a 1300K, just as I do, and they also found significant differences, but I cannot compare their results to mine because they use Cinebench to benchmark coolers. Now, there is a very specific reason why I do not use Cinebench to benchmark coolers, because if you use Cinebench, even if you loop it for, let's say, an hour, no, it doesn't really matter how long, if you loop through it, it will start up, it will, give everything on the CPU, it will do whatever it has to do, and then in between the loops, it will, for a very brief moment, it will drop and then it will mount up again. And because of that drop, for me, that is not a sustained workload. You switch it up for a millisecond. Now that's not an invalid way of testing. It's why the hell not? It's just not what I do. And I think, or I suspect that having that drop will dramatically change how different coolers perform in comparison to each other. My theory here is, I think that's quite easy to understand. If you compare the exact same cooler with two different sets of fans, for me it makes total sense if you exchange on one cooler the fans for very brutal ones. Because of that millisecond or second long drop to the bottom in between the loops, because of the brutal fans, they will have a very positive impact on that brief moment. They will push the temperature down because there is nothing coming anymore, and the more brutal your fans are, the more down it pushes it. I hope you understand what I'm trying to get to. I'm like very sleep deprived, so I have a hard time explaining what I mean here. But Cinebench is not a sustained workload, not if you test a cooler. So I don't think we can compare whatever that website. I'm not saying he is wrong, I'm just saying it's not the same type of testing, so not really comparable. I was very unsure why it didn't perform. I'm not saying Arctic is wrong. I'm not saying this graph here is an over-exaggeration of whatever Arctic created here. I'm saying this is specifically for the new Intel generations. And although Arctic provided me a list, the benefit, if you step it down to Intel 14th gen, are much smaller already by Arctic's measuring. And I found that if you go even further down than that, the benefits become even smaller. Even smaller. I found 2 degrees C at max if I give it all, and the noise to performance ratio, although I can cherry pick, and I'm not saying Arctic cherry picked here, I'm saying if I take my graph and if I cherry pick my results, I can create the same distance or difference to the original one. But overall, for a 3900K, I do not see a huge improvement in the noise to perform, any improvement in the noise to performance, and only a improvement in max performance. But that did not apply on my AMD setup. Over on AMD, we benchmark using a 7950X3D where we average the core clock speed across all cores and across the whole fan speed spectrum to create a noise to performance curve. And unlike my Intel benchmarks, I can say that using a Pro version on a Ryzen 7000 X3D chip makes a lot of sense. Sure, at the very end it gets much louder without having so much more benefit, but that's just the nature of having this exact chip. But if we normalize it down to the LF3 original, the Pro kept the chip clocked higher consistently, or it keeps the same performance level at a much lower noise. And I know that this also is not a apples to apples comparison if we compare that to Arctic's claims, as they use a non-X3D chip. But even in my slightly different approach, max performance, the LF3 Pro takes the lead, and noise normalized, it takes it too. And even if you push it all the way down, let's say to slightly above noise floor at 36 dB, the Pro is still a good step better. So was this upgrade worth it? Well, as for my benchmark setups, if I had a Ryzen whatever, definitely yes, this is way better if I had an AMD chip. Sure, these fans are much louder than the original P12s, that's definitely true, but once they are turning slower, once you lock them down, your noise to performance ratio is significantly improved over the original ones. For Intel, however, as I've said like 10 minutes for a 10-minute segment of this video, I just cannot say that this was an upgrade using my 3900K. I really hope that somebody who benchmarks using the new LGA 1851 chips, or also somebody who can maybe verify mine on a 3900K using a sustained workload, comes around. But as for my benchmarks, if you have an older chip, the benefit becomes smaller and smaller until it just becomes zero. That's my issue with the Pro Series Aero as a whole. I found that having this over the original on a 1300K is just not a good idea. If you want to look at the whole spectrum. Sure, the max is better, the min is better if you look at that portion specifically, but overall, I cannot say that this is an upgrade for my 3900K. I also want to say something else which is very important. I am not saying that this is a bad AIO overall. I'm not saying that. I am saying if you, for example, take my Intel benchmarks, the noise to performance graphs, and you map it or you compare it to any other AIO, which is not an Arctic AIO, it is still a very good option on the market right now, especially for the price, and we'll get to that. I'm just saying the upgrade from a regular LF3 to this one on my specific setup is not worth it. Take for example the Montec Hyperflow in 360 at 320 watts. The Pro beats its ass across the whole line, and below 65% fan speed the Galahad 2 Lite can't keep up either. All I'm trying to say here today is if you have an older Intel chip, just use the normal one. Based on my testing, you will be better off for the majority for the middle section of the run. But if you compare it to other ones, it's a good AIO. And what is also good about it is the price. It is going for 93 euros on Arctic's own shop. And that just makes sense. Now, something I also want to get out there today, even if this 3000 RPM Pro version of the Liquid Freezer is much louder at max compared to the original, I still would not describe this one as like loud in a broader sense. For 3000 RPM fans, I think they are survivably quiet. Don't get me wrong, they can get loud. I do batch record my AIOs. So I had, for example, the Corsair Nautilus 360, which was measured just before this one, and it wasn't really that much quieter. But okay, this should be everything on the new Liquid Freezer 3 Pro in 360, and at this point a huge thank you to Arctic for sending this one over. Oh, on a side note, we have a Discord server, so if you want to join, the link is down below. And we got channel membership, so if you are planning to sell your soul for an RG poop emoji, that's one way to go. But if not, I'm also releasing the content to all members 2 or 3 weeks in advance. Except for the NDA stuff, because, you know, I don't want to get sued. Additionally, you can rest assured that the income will not only keep the channel afloat, but will also serve to... Remember the giant fighting pit with all the liquid freezers? Anyway, thank you for watching, and if you want to continue, have a look at our take on the Silent Loop 3 in 420 I released some time ago. Different AIO, but maybe that one is more of your thing. Hope to see you on the next one. Bye bye.